This section is probably the main reason you're taking this course. It's about acids, bases, and neutralization reactions. I've assigned all the homework because it is really, really important. And what we want to teach you here is that when you have an acid and when you have a base and you pour them together, they make water and they make a salt. Here's the list of the acids. Here's the list of the bases. You do need to memorize them. So let's get started. What is an acid? An acid is something that produces a hydrogen ion, an H plus, in aqueous solution. They can be strong, those are the ones that have a single arrow, or they can be weak, those are one that have a double arrow, and it depends on how much they ionize. These first two acids, they are strong acids. The vinegar that's in your salad dressing, it is a weak acid, and they're going to have different behaviors. You see a Ka. Maybe some of you had a evil high school teacher and made you learn it, but you'll learn about that in 1220. Acids can be monoprotic, where they have just a single hydrogen, or they can be diprotic, where they have two hydrogens. And the first step for a diprotic goes to completion. You see a single arrow. The second step, it does not. You see the double arrow and also that Ka that we'll talk about in chemistry 1220. There are also the bases, and they produce OH minus in aqueous solution. They can also be strong or weak depending on their extent of hybridization. You do need to memorize these 7 strong bases. They come from group 1A or group 2A on the periodic table. The most common weak base that you're going to run into in our class is ammonia, and it does have an unusual equation because you need to put in water in order to balance it, and it has that Kb that we'll talk about in Chem 1220. But for now, we just want you to know 7 strong acids, 7 strong bases, what's a weak acid, what's a weak base. So the key to this section is the neutralization reaction. Notice we have an acid, nitric. We have a base, calcium hydroxide. It is producing water and a salt. And that salt is really a general term. It means an ionic compound. We have the cation from the base, and we have the anion from the acid. Going a little deeper, you got to learn to balance a neutralization reaction, and it's the same method that we use in precipitation. Here we have a strong acid, here we have a strong base. We need to produce water as a liquid, and whatever salt is the result from that acid and base. Not very hard, but watch, sometimes you do have to balance. The harder part is the complete ionic equation. And I'll try to write small so I can squeeze it all in. 2H plus 2 NO3 minuses plus a Ca2 plus 2 OH minuses goes to form water as a liquid, and this being a strong electrolyte, remember all nitrates are soluble. It makes Ca2 plus aqueous and 2NO3 minus aqueous. That is our complete ionic equation. When we write the net ionic equation, we cancel out the spectator ions, and I've done it here. It results in 2H plus aqueous plus 2OH minus aqueous going to form 2 waters. Now we always reduce it down to the least common denominator for our equations. So it's H plus OH minus going to form H2O liquid. Now this is always the result for the reaction of a strong acid and a strong base. If you're asked on an exam and you've got your 7 memorized, you don't have to go through all these steps. You always know it's H plus OH minus. It changes if we have a weak acid. How do you know it's a weak acid? It's not one of the 7 strong acids. I could say this till I'm purple, but many people just refuse to memorize those 7 strong acids. So HF is a weak acid. And notice, in the net ionic equation, it does not separate. Weak acids never separate. The strong base, it definitely does separate. We're able to get rid of the common ion from the cation from the strong base. And notice the net ionic reaction. It still has the weak acid, and it has what is called the anion of the weak acid. You'll learn about that in Chemistry 122. But for now, if you can teach yourself this, you'll be yards ahead, miles ahead in Chemistry 122. So we've talked about strong acid, strong base, weak acid, strong base. We do not do weak acid, weak base. Just does not happen in a general chemistry course. Too complicated. The other thing I need to point out is that you can form gas. If you have a carbonate ion and you react it with acid, you will form carbon dioxide. If you have a sulfite ion and you react it with acid, you will form sulfur dioxide. If you have a sulfide ion and you react it with acid, you will form H2S, hydrogen sulfide. So what's sitting at the bottom here is really the driving forces for chemical reactions. And this again gives you insight. That's really, I've got to teach the facts, I got to teach the methods, but I want to teach you to understand things. Anytime you can form a solid, you can't stop that chemical reaction. It's just going to take place. We call it a driving force. Anytime you can form water, which is this section, you can't stop it. It is just going to happen. It's a driving force. And listed above, those 3 anions that form gases, if there's acid present, you cannot stop it. So I'll talk about this in the lecture Zoom about hydrogen sulfide. It is poisonous, and I'll leave it at that. It'll make you come to the lectures. 2 things before we wrap this up. Here's a stretch. What's going on here? I have magnesium hydroxide. It is an insoluble solid. But if I add it to a strong acid, it is going to dissolve. What's going on? Well, there's the picture you can look at from your text, but here is the hydroxide ion. Here is the H plus ion. They're going to combine to form water and some magnesium chloride. So maybe you've heard people have acid indigestion, and they will take an antacid. Okay? Well, that's the last slide of this section. There are common antacids, and you may be surprised at the formulas. They're the things that we've talked about in this section. And what they do is they can neutralize heartburn. There's the pictures that you'd buy in the drugstore. There's their formulas. I have to mention, since a lot of you may be going into medicine, there's also things called acid inhibitors that act on the cell lining. And I want to point out, you already know about formulas. You already know about molecular weights. So again, it is a rough start for Gen Chem. There's a lot to learn. If you don't have a strong background, I encourage you to please put in the time. You can be successful in this course. Please ask questions. It's a little more difficult with us being online, but I do think we can all be successful. I and your teaching assistants are here to support you 100%.